Here we're talking about simplifying radicals. A radical is something that you're familiar with. You've seen square roots and cube roots before. A radical is just a general term for any root that we take. You can take a fourth root, you can take a fifth root. Those different roots are under the umbrella of radicals. And we can simplify radicals by basically factoring out any square root or cube root, any appropriate root for that radical. To do that, we need to understand the properties of radicals. And basically, we just need two of them, product property and quotient property. When we're multiplying two things inside a square root, we can multiply them separately as separate square roots, just like what's shown here. A times B is under the square root symbol, under just one big square root symbol. That's the exact same thing as taking the square root of A and taking the square root of B separately and then multiplying them together. We're going to need to use that going backwards and forwards. We're going to need to combine from this to that and vice versa. We're going to need to split it up sometimes. And basically that's what this rule is saying. The square root of a product, the square root of a multiplication problem, is the same thing. It equals the product of the square root of each factor. So we just basically split it into separate square roots and still multiply. It works the exact same way with a division problem. The square root of a quotient or division problem equals the quotient, the division between the square roots of the numerator and the denominator. So we can take the square root of the whole division problem, or we can split that into the square root of the top divided by the square root of the bottom. The operation still stays the same. It's still dividing those two. It just becomes two separate square roots. So here we have four different examples. The first two we're going to write as a product of square roots instead of just the square root of one number. So there's a bunch of different ways we can split this up. I'm going to split 60 into two separate square roots. I'm just thinking about anything that's any two factors of 60. So I'm just going to choose 3 and 20. The square root of 60 is the exact same thing as the square root of 3 times the square root of 20. I could have also chosen any other numbers that multiply to 60. So I could choose the square root of 4 times the square root of 15. That's the exact same thing. For 200, I'm going to pick 20 and 10. But again, that's not the only choice that I could have. I can also say the square root of 2 times the square root of 100. The two numbers that multiply to get us 200 stay under the square root symbols, and they're still multiplied. Now it's just two square root symbols instead of just one. Same thing with the quotient. I'm going to split this into two separate square roots, the square root of 1 and the square root of 9. Actually, that's following the instructions. It's saying rewrite it as a quotient of square roots. That is the quotient of two square roots. We're dividing two square roots. But I'm going to simplify that further just because I know I can simplify that. That is the exact same thing as 1 over 3. The square root of 1 is just 1. The square root of 9 is 3. On the fourth one, I'm going to split that into two square roots. The square root of 10 divided by the square root of 4. And I know the square root of 4 is going to be 2, so I can also simplify that one. That's the square root of 10 divided by just 2. This is a key first step into understanding how to simplify these. These actually aren't simplified, but we're going to take that one step further to actually make these more simple. So when I talk about simplifying a radical, I'm talking about resolving all perfect squares. All perfect squares that are under the square root symbol. A perfect square is a product of any two integers. And basically, that means they're not decimals. They can be positive or negative. They can be 0. They just can't be any decimal. And one way to find these perfect squares really easily is to use the prime factorization. And a prime factorization basically means we're breaking a composite number, we're breaking a not prime number down into its prime factors. Or we're just factoring it as completely as we possibly can. So we're going to take that first example, 48, and we're going to split that into two factors. I'm just going to choose, it really doesn't matter, but I'm going to choose 6 and 8. You could also choose 12 and 4. You could choose 16 and 3. Really, however you want to break it down is depending on what you see first and what you might think is the easiest. I'm breaking it down into 8 and 6. It doesn't have to be broken down that way. 6 does need to be broken down into two specific numbers. That's 3 and 2. 8 can be broken down a couple different ways. I'm going to call it 4 and 2 there. And then 4 is going to split into 2 and 2. That is the prime factorization of 48. 2 times 2 times 2 times 3 times 2. I'm not using the 4 or the 6 or the 8 because those aren't prime numbers. The last step is all I'm using. 2, 2, 2, 3, and 2. Those are the farthest that can be broken down. You can't break those down anymore because nothing divides 2 or 3 evenly. Those are the primes that multiply to give me 48. I'm going to condense that a little bit. I see that I have 2, 2, 2, 2. So that's 2 to the 4th power times 3. 2 to the 4th power times 3 equals 48. I'm going to break down 24 into 2 and 12. 2 doesn't break down anymore, so that one's done. If I can break down 12 more, I'm going to break that into 3 and 4. 3 doesn't break down any farther, but 4 will. That breaks down into 2 and 2. And that's all I can do to break that down. So I have a 2, a 3, a 2, and another 2. So 2 times 3 times 2 times 2 equals 24. Another way to write that is saying that 2 to the 3rd power, 1, 2, 3 of them, times 3 equals that 24. And this should make sense, at least this comparison between these two. That versus that. 2 times 24 would get us up to 48. That's why this has an extra 2 in it. It just has one more 2 as a factor. So this is still not simplifying radicals yet. This is just one more step. We're basically going to put these two things together and eventually simplify radicals. I'm going to show you how to prime factor one more number. Let's take 160. Again, you could break this down into any numbers that you want that multiply to be 160. I'm going to choose 4 and 40. Both of those are composite numbers. I can break those down farther. That's going to give me a 2 and a 2. 40 can give me a 2 and a 20. I can't break down 2 anymore, but I can break down 20. That's going to turn it into, let's call that 5 and 4. 5 can't be broken down anymore. 4 can, that's a 2 and a 2. And those are all of my prime factors of 160. I have 1, 2, 3, 4, 5, 2s. 2 to the 5th, and a 5 times 5. That equals 160. That step is the prime factorization of a number. You're just breaking it into all of its primes. We're basically going to take that with these two properties and simplify radicals. That's what we're going to do on this page. So these two properties together, the properties of radicals plus the prime factorization, allows us to easily simplify radicals because we're easily able to identify the pairs of identical factors. When I say pairs of identical factors, I mean a set of the same factor, 2 of the same factor. Here we have 2 2s and 2 3s and 2 3s. Those are pairs of factors that make it really easy to simplify any radical. Each pair is going to simplify to a single factor outside of the square root symbol. So we're effectively going to take the square root of that pair. Actually, I'm going to show it in that example. If I think about this, the square root of 2 times 2 times, I'm using that property that we learned before, the square root of 3 times 3 times the square root of another 3 times 3. The square root of 2 times 2. The square root of what is really just 4 is 2. The square root of what is really just 9 is 3. And the square root of another 9 is really just another 3. Those come out as factors outside of the square root, and I have just one of them. So I had a pair of them. I had a pair of 2's inside of there. That came to the outside as just 1 2. I had a pair of 3's. That came to the outside as just 1 3. I had a pair of 3's inside the square root symbol. They're under the square root right now. But when I take the single factor out of there, it shows up as just 1 3. And when we think about the result of this, 2 times 3 times 2, all of that basically just changes into 18, which is the square root of 33. Okay, now our calculator can give us nice whole square roots like that, but sometimes it doesn't simplify nicely just into a whole number. Sometimes it won't turn into just that. Sometimes there's going to be stuff left on the inside of the square root. That's what we're going to see on the square root of 20. So I'm going to break this down into all of its factors first. 20 split into 4 and 5. 5 doesn't break down anymore, but 4 will. That'll break down into a 2 and another 2. So the factors of 20 are 2, 2, and 5. The prime factors are 2, 2, and 5. That's still under the square root symbol right now. All I did was change that 20 into basically just a multiplication problem of smaller numbers. Now I notice that I only have 1 5, but I have a pair of 2's. That pair of 2's is going to get factored out. I'm going to show this in a couple of different steps, but eventually we're just going to shortcut this. So I'm going to show this as 2 separate square roots. That's the square root of 4 times the square root of 5. That's what the product property allows us to do. We're splitting this into 2 separate square roots so that we can take the square root of the 4, simplify that into just a nice whole number, which is just 2, and then put that on the outside of the square root that we have left. Okay, so we have a 2 times the square root of 5. That 5 stays under the square root symbol because that didn't have anything to pair up. The 2, one of these 2's came to the outside of the square root because we're really taking the square root of 4, which just leaves us with one of these integer factors. One of those 2's is still left, but it's coming to the outside because we actually took the square root of those 2 numbers being multiplied together. Alright, on the square root of 200, the first thing all I'm going to do is really just break down this 200 into its prime factors. So 2 times 100 would give me 200. 2 is as simple as that gets, but I can split this into 2 and 50. I can split 50 into 2 and 25. And then 25 splits into 5 and 5. And that's a list of the prime factors that multiply to get up to 200. So that's 2 times 2 times 2 times 5 times 5. And to make sure that you did this right, you can always just multiply this back out. 2 times 2 times 2 is 8, times 5 is 40, times 5 again is 200. So you can check to make sure that you actually have the right number of factors inside of here. From there, we're looking for the pairs that match up. So I have a pair of 2's, and I have a pair of 5's. This 2 is going to be the only thing left on the inside of the square root symbol. Everything else found a pair to match up with and come to the outside of the square root. So I'm going to have 1 2 on the outside, and it's still being multiplied. Everything here is still being multiplied. I'm also going to have 1 5 on the outside. So it's almost as simple as it gets. I'm still just multiplying these numbers, so I'm going to multiply the 2 and the 5 together. That gives me a final answer of 10 times the square root of 2. And you can write the multiplication symbol, but you don't need it. Having a 10 outside of the square root like that just implies that we're multiplying those two together. The numbers that you're really looking for prime factors, don't write this part down, but the key prime factors, the primes that we're really looking for are 2, 3, 5, and 7. Not saying those are the only ones. You can have 11 and 13, other smaller primes, but those are the big ones that you're going to see, 2, 3, 5, and 7. Once you get down to those primes, you're done. And usually those are the only primes that these are going to simplify into. If you're not sure what something divides by, like this, 243, I don't immediately see what that's going to be divided by. I know 2 doesn't divide it nicely. I know 5 doesn't divide it nicely. So I'm going to try 3 and 7. I'm going to try 3 first. So if I divide that by 3, that actually is going to work out nicely. That's going to give me 3 and 81. 3 doesn't simplify anymore, but 81 will. That splits into 9 and 9. And then 9s will split into 3 and 3. So I basically just have 5 3s here. So it's the square root of 3 times 3 times 3 times 3 times 3. Like I said it 5 times. And now I'm thinking about which pairs I have. I have a pair of 3s there. I have another pair of 3s there. When they find a pair inside the square root, one of these guys is going to come to the outside. One of these guys is going to come to the outside. So I have 3 times 3 on the outside. And this guy, unfortunately, he did not find a pair to come to the outside, so he's going to stay on the inside as just the square root of 3. These guys go away because they found a pair. And we did basically, what we did is the square root of 9 to get this 3 on the outside, and another square root of 9 to get this 3 on the outside. And we take one more step to simplify that completely. 3 times 3 is 9. And that is as simple as it gets. All right, so you might understand this by now. If you don't, I'm going to continue just working through these practice problems. So on number 1, we're trying to split that into whatever factors we see. I see that it's an even number, so I'm going to split that into 2, and 112 divided by 2 is 56. 2 is as simple as that gets. 56 splits into 2 and 28. 28 will split into, let's say, 4 and 7. 7 is the prime, so that's done. 4 will split up a little bit farther. That splits into 2 and 2. So inside the square root, we still have 2 times 2 times 2 times 2 times 7. And I see I have a pair of 2's here. I have a pair of 2's there. And that 7 did not have anybody to pair up with. He's going to stay on the inside of the square root. And I'm going to bring out the 2 2's. It's going to be 2 times 2 times the square root of 7. Or 2 times 2 is just 4. We have 4 times the square root of 7. And you can always make sure that you're getting these right. The square root of 112 equals this product, 4 times the square root of 7. All right, on the next one we have a coefficient of 1/3. We're really going to deal with that at the end. It's going to be 1/3 times, it's kind of like what we did in the last step here. We're basically just simplifying the stuff on the outside. So it's going to be 1/3 times whatever we get from simplifying the square root of 54. That is going to split into 2 and 27. 27 splits into 3 and 9. 9 splits into 3 and 3. So I'm showing that prime factorization just a little bit differently there. This is all still under the square root symbol. So now I'm looking for those pairs. I have a pair of 3's in the middle, and I have a lone 2 and a lone 3. They're still going to be on the inside of the square root symbol. So it's going to be 1/3 times one of these 3's is going to jump to the outside. Everything else stays on the inside. This 2 times 3 is still on the inside. I'm going to simplify the outside and the inside in that same step. 1/3 times 3 is really just 1. And the square root of 2 times 3 is really just the square root of 6. It's 1 times the square root of 6, which is really just the square root of 6 by itself. Alright, and then the next one, we run into a problem. You can divide this by any number that you want. The only thing that divides it is 71. Well, 1 and 71. It's a prime number, as it is. If there is a prime number, that's as simple as that gets. The answer, the simplified version of that, is already given to us. The square root of 71 is as simple as that gets. It's a prime number. All right, number 4, we have a quotient. So we're going to split that into 2 separate square roots. That's really the square root of 90 divided by the square root of 100. The square root of 100 you know right away, or you should. That's just 10. So I'm going to simplify that right away. This is going to become the square root of 90 divided by 10. This can be simplified. So I'm going to break that down into its factors. Into 2 and 45, then 5 and 9 from that 45, and then from that 9 I can break that down a little bit farther, giving me 2 3s there. So the square root of 90 is really 2 times 5 times 3 times 3, and that gives me 1 pair of 3s in there, which means I have 3 times the square root of 2 times 5, or 3 times the square root of 10. This is still a fraction. I got to rewrite that whole thing. So I changed the bottom into just 10. This is 3 times the square root of 10 on top, divided by just 10 on the bottom. If you could simplify that fraction, you do want to. So you want to pay attention to these numbers in front. That 3 and that 10, they don't simplify here, but they might. So you have to be aware of that, and you want to simplify that fraction as much as you can to have a completely simplified answer. And the next one, we have a product of 2 square roots. So there's 2 different ways we can handle this. We can factor each of them separately, or we can multiply them together and then factor them together. It's going to be a little bit quicker to just factor them separately. So I'm going to start with that because they're already actually a little bit factored. So just taking one step away. This factors into a 3 and a 2. That's as far as that goes. And 8 factors into a 2 and a 4. And 4 can continue factoring into 2 2's. So when I multiply all of this stuff together, I really have the square root of 3, 2, 2, 2, 2. That gives me 2 pairs of 2's that are going to come to the outside. One of these is going to come out. One of these is going to come out. That gives me 2 times the square root of that 3 did not find anybody to pair up with, so he stays on the inside. And then to finish simplifying, I just multiply 2 times 2 to get 4. And the square root of 3 is still left on the inside of that square root symbol. All right, the next one, number 6, is asking us to find the area of that rectangle. The area of a rectangle is the length times the width. So it really doesn't matter which one's length and width. I'll call this one length, I'll call this one width. And I'll say the square root of 30 times the square root of 2 equals the area. I want to simplify that as much as I can. So I'm going to simplify the square root of 30 a little bit. The square root of 2 can't simplify at all because that's already prime. So I have 1, 2 right now. And I have the prime factors of 30, which are 2, 3, and 5. I actually broke that down into its prime factors right away. 2 times 3 is 6, times 5 is 30. So I know that these are the prime factors in that multiplication problem. I'm going to put that under one square root symbol, 2 times 3 times 5 times 2. And I see that I have a pair of 2's here. Oops. I got a pair of 2's. So one of those 2's is going to come to the outside. And I'm going to simplify on the inside. That's 3 times 5 on the inside, or 15. And that's as simple as the area